All right, welcome everyone to our new episode of the Osert podcast. We have the pleasure of having Lesley Carhart with us today. Thanks so much for being with us today, Lesley. Can you tell us a little bit more about yourself?
Well, thanks for having me. It's very nice to meet you. I'm Lesley Carhart, and I specialize in a very strange area of digital forensics and incident response, which is working on industrial systems. So I'm one of the few people on Earth who gets called out when something like a train or a power plant gets hacked into to investigate what happened, how it happened, and remediate it.
That's amazing. So what are some of the? I mean, I know that probably there's no day that is the same as the following day in your career, and just by describing it, you made it super interesting. What are some of the most typical instances that you have to deal with?
First of all, it's absolute chaos. I never know what to expect every day. Certainly, I do proactive work when I don't have cases. I do things like incident response preparation and tabletop exercises for customers. But the cases that I get are kind of broken into three broad categories. So the first one is commodity stuff. So ransomware impacts industrial networks too, so does older worms and pieces of malware because they have Windows systems in them and commercial IT systems inside them that are doing important things. So like 1/3 of my cases is that type of commodity criminal stuff. The second third is insiders, and not necessarily malicious insiders, although we do see that happen. Certainly the first industrial cyber attack actually was in Australia in Maroochydore, which was a disgruntled employee, former employee, who dumped raw sewage into a water reservoir using his computer that wasn't taken away from him when he was fired. And so there are insiders in industrial organizations who decide to do bad things with computers. But most of the time, the insider cases are just people trying to do their jobs and evading security controls because security makes their lives hard, or they don't understand the security controls, or they're just bored and they want to watch a movie in the middle of the night at their remote mining FIFO site. So there's a lot of that going on too. People plugging in antennas, hooking things up that shouldn't be hooked up, and sometimes it's not caught for a really long time, and it can have big cybersecurity implications. But the last category is the kind of scary one, which is the state-style stuff. So I'm talking about sabotage and espionage, industrial espionage. And that's been going on as long as human civilization has existed. That hasn't changed. But now there's computers connected to these devices, and they're remotely accessible from across the planet. And that saves the state adversary spy agencies from having to send James Bond across the world. So now they can do some of their activity when it makes sense via computers, and we're dealing with the fallout of that. And the end result there is that every country with the capacity to do this type of thing is trying to get embedded in the networks of everybody else, so that if they have a conventional war or some kind of political dispute in the future, they have the capacity to do sabotage or espionage remotely.
That's very interesting. I wanted to kind of pick up on this last point that
Sure.
you touched upon on the countries trying to have people embedded in those systems. What's the approach to be used in that space? Is that just a matter of responding when the thing happens, or are there steps that organizations, especially in the industrial space, can take to prevent that from happening? Is there a mix of both? What's your view on
It's
this?
defense in depth like anything else. We would like to catch them early. They're very hard to catch. They're oftentimes not using typical tactics that you'd see in an enterprise. They're not using a lot of malware or commodity hacking tools. They're oftentimes low and slow living off the land attacks where they steal administrative accounts and they just utilize the built-in administrative tools. So it's very hard to pick up. That said, any increase in detection maturity and cybersecurity maturity helps deter that and catch it early before something malicious is done. So all we can do is keep building onto our detection and our defenses and our architectural controls to try to catch those early, catch that embedding and reconnaissance and spycraft early before it's used when there's a geopolitical reason to do it. These countries are spending a ton of money and resources on this very quiet intrusion and espionage. They don't want to make something explode today. They want to be ready to do that should there be a geopolitical circumstance in the future. So they're trying to be quiet. They're trying to not get caught. And if you can catch them, that throws a big wrench in their plans.
And as you mentioned, the specificity of working in the IT/OT space is the fact that you're dealing mostly with complex systems, with large industrial plants and networks and organizations, and obviously the repercussions on IT incidents can actually have very, very physical consequences, critical infrastructures and so on. Can you tell us a little bit about some of the most eminent impacts or consequences you've seen in your career?
Yeah, I mean, it's tough for me to talk about specific cases that haven't made the news. I've worked on a lot of the major cases that have made the news over the last 10 years. In terms of near misses, I've seen a lot of near misses. I've seen things come very close to there being a catastrophic impact on all different types of critical infrastructure systems, from medical systems to agricultural systems to transportation to traffic light control to biopharma, and a lot of those were near misses where things were caught just in time. One of the public cases is like Trisis, the case of a toolkit being developed, to a piece of malware being developed to tamper with safety systems. Wow. And that was caught before it could do harm. Thankfully, there was an error in the code that allowed them to be caught, but that could have been catastrophic, breaking people's safety systems and their industrial processes. But the really important thing for cybersecurity, enterprise cybersecurity people to understand about these types of environments is things have real life consequences. Somebody breaking these systems of systems, not necessarily a single device, but breaking the process itself, can result in somebody dying. It can result in systems being down so long that a company goes out of business. But that's the best case scenario, because the worst case scenario is catastrophic industrial accidents. It's facilities catching on fire, it's people being injured, it's people dying, it's the environment being contaminated. So very real life kinetic impacts of these things. And we've obviously seen numerous successful, to some extent, cyber attacks against critical infrastructure in Ukraine during the actual conventional conflicts there, which is how adversaries are utilizing these attacks. They're waiting until there's a purpose to use them, and then they are doing things like shutting off the power like they did in Ukraine.
Yeah, that's very interesting. And look, you mentioned the concept of systems, and you gave me a massive flashback right there, because I did actually my PhD on safety and security critical systems in international airports in Australia. So it kind of brought PTSD at the same time, but also excitement, thinking of how the all safety and reliability engineering frameworks are actually more and more closely connected with the cyber components. As someone that I've seen it in international airports, it's very difficult to distinguish between the two pieces. The separation is not really immediately there. You have tightly coupled systems, you have interactive complexity going on, and that kind of really makes the trickle-down effect much more impactful and the blast radius potentially larger.
Yes, so we do a lot of hazard analysis as part of our risk modeling for industrial cybersecurity for the same reasons. And a lot of that's already been done in these environments from a maintenance and a human error perspective. But somebody maliciously tampering with the system is very different than an individual device or set of devices failing. Devices fail all the time in industrial environments. There's industrial accidents and maintenance problems all the time. Devices have to be replaced, they fail, they have errors. But that's why these systems are full of safety controls and redundancies, to prevent the whole system, the whole process from failing when a single device or a single piece of logic fails, or a human makes a mistake. But that's different than a dedicated adversary, whether they're criminal or they're an insider or they're a state doing spycraft or industrial sabotage. That's different, because in those cases they are doing a concerted attack against the whole system. So maybe they're breaking 8 devices, and they're breaking the redundancies, they're breaking the safety mechanisms, the digital safety controls, or evading the physical safety controls. So they're looking at how to purposefully break the whole process, which is a lot different than just a single device failing. And the resilience of these systems does somewhat resist simple cyber attacks. It's why we don't see cyber attacks taking down the power every week. It is hard to shut off the power. It's hard to set a facility on fire, a chemical plant, because they're full of safety controls. But somebody who's in those systems, spends time with them, whether that's an insider or a spy who sits there for 5 years, they can figure out how to evade all those safety controls, and when they need to, break all of them at once. And the tolerances for hazards and the mitigations for those hazards in the industrial environments aren't engineered to tolerate that.
Very, very interesting. And Lesley, we are wanting to get to theoretical and academic. You probably might be aware with of the work of Nancy Leveson from MIT.
Yeah.
And I'm a big fan of her work. And one of the things that she really focuses on is the fact that failure in complex industrial systems can be all brought back to design failures and design weaknesses, right? Something failed because there were not the appropriate controls and feedback loops in place for us to pick up on the failure. Do you think you have that, and then you add the security piece, right, which is somebody intentionally doing stuff, which is not really what happens typically in the safety world. Do you think that even the security failures being vulnerable and compromisable, and these systems being compromisable, are essentially design issues? What I'm trying to ask is, can we design for security?
Yes, absolutely. And that's something that organizations are having to confront and deal with now. These adversaries weren't at the state of maturity that they are now 5 years ago or 10 years ago, but now there's states, there's criminal organizations, there's insiders who have the capacity and the knowledge of these attacks existing to want to do them. And so they've had to play catch up, and that's globally. It's really interesting to me. I go to countries all over the world and I talk to their governments about critical infrastructure, because there's not many of us who do this. And every country, somebody pulls me aside and they're like, are we the worst ones? Lesley, tell us, where do we stand compared to everywhere? Tell us we're not the worst ones. And everybody's dealing with the same challenges. That's the bottom line, is this is hard, but it's doable. So there's a good white paper out from SANS called The 5 Critical Controls for Industrial Cybersecurity, and it breaks it into 5 basics to build up to defend against these attacks. And the first one is just having a plan, for incident response plan for cybersecurity, as opposed to normal maintenance problems, failures. The second one is architectural controls, and that's really important. Things like secure architecture, segmentation, zero trust, things like that. The third one is detection, having visibility, network visibility, to see what's going on in the environment and catch some of this stuff. It sounds really basic, but that's where we're at. And then remote access management, because every vendor, every OEM wants remote access into these environments now.
Of course.
And so it makes them very exposed when they were never intended to be exposed. And finally, risk-based vulnerability management, so understanding what's exposed and vulnerable and what things can and cannot be updated or patched in the actual practical industrial environment. Understanding that is important. So there's things you can do. There's 5 categories of stuff right there, and even if you start at those things, it makes a difference. But everybody's having a hard time.
Absolutely, I really agree with that. That's super interesting. As you probably got, I could talk about these things for hours, because it's really, I got a passion in this kind of connection between security and safety and reliability engineering.
Yeah.
Now, I wanted to kind of change topic for a second. It's something that before our recording, we were chatting. You were talking about the struggle that you see in hiring people interested in IT, OT, and industrial control systems, and working in this area, because everybody wants to work in more exciting spaces, agentic AI. Yes, exactly. I'll use their words probably. Agentic AI and all this stuff, and they don't really want to deal with Windows 95 anymore. Can you elaborate a little bit on those challenges? Is it really that hard to hire people in the ICS space?
It is, actually. It's very hard, especially at the mid-career level, and even juniors. And and I do a lot of mentorship and teaching in the junior space. I'm very passionate about getting young people into cybersecurity. And I know how bad the market is right now. It's really, really bad globally for young people. And some people are giving up. They cannot find a break-in to get into the field. But at the same time, I have positions open in OT for months. It's very, very challenging to hire people. And it's a foundational education problem usually. There's a lack of interest. A lot of people want to do, they spend all their time, all their projects, all their time in their studies focusing on the next cool technology, the AI, the agentic stuff, you know, quantum, things like that. And that's fine. That's neat stuff. But I work on Windows 95 computers in power plants and on trains. Like, I see Windows NT on a regular basis. And to be able to teach somebody how to work with those old computers, they have to have really good foundations with computers. I can teach people tools all day. This is not gatekeeping. Like, I can teach people tools, forensics tools, all that stuff I can teach. I need them to know how hard drives from the 90s work, though.
There you go.
I need them to understand file systems and looking at packets without EDR, without LLMs, without any of the AI-based SWOR or SIEM platforms that are out there today. I need them to be able to work on old computers and things like assembly. And that's a dying skill set because curriculums are so focused on next generation technology right now. I don't know where I'm getting my next generation of professionals. I really don't. It's really scary. And we're having the skills are diverging more and more. The skills to do what I do in OT versus a DFIR analyst in enterprise are vastly different and becoming more and more different by the year.
So if you were to kind of sell working in this space to a junior professional or a newly graduate that wants to crack into the cybersecurity industry, what are some of the things that you would point out? What would working in this area equip them with? How is it exciting? How is it interesting?
There's nothing more important in the world. We're keeping society safe. We're keeping people's daily lives, the things that you don't think about because they never fail, like water coming out of the taps that's safe to drink, your toilets flushing, the things that never break, that you never have to think about failing. We're keeping those things from being tampered with and failing. And the impacts of things like sewage not working on society are, you don't want to think about them. They'd be catastrophic. So the work is fascinating. It's meaningful. There's no ethical quandaries about doing it every day. You don't have to like the oil pipeline company, but if the pipeline explodes, that's really bad. And you know, just the work is so intriguing because it's not just like ransomware cases all day. Not that there's anything wrong with being an incident responder and focusing on ransomware, but I have a different case every day. I don't know what era of technology I'm going to be working for. I don't know what industrial process I'm going to learn. It could be egg packaging. It could be fertilizer making. It could be trains. It could be aircraft, avionic systems. Just completely varies by the case. So it's always interesting, it's always challenging, and it's always meaningful.
And look, working in that space would certainly equip people with foundational and really solid basis to then possibly, you know, branch into other areas, intimately knowing an industry and really looking at the core of the processes that make that whole industry work. I really like what you're saying. It's almost like you are authors of your own misfortune. You're doing too good of a job in that space. People don't really fail, and we take them for granted. But that doesn't mean that there's not a lot of work that needs to be done to secure those foundations.
The fact that a criminal or an insider or a state has chosen to not make something explode is not a reason to not build these programs. It's them making a choice not to make things explode today or this week. And usually, again, they're waiting for like a geopolitical or political circumstance to do that because it's so expensive. You do not want to wait until they make the decision to break something to build a cybersecurity program. You need to have all these things in place before then. You need to prevent it. You need to keep it from actually occurring or occurring with severe consequences. So I understand it doesn't build security budgets when people do espionage or foothold building or initial access, but the results, if you don't catch it at that stage 6 months later or 6 years later, are going to be so bad.
Are there any particular skills or personality traits that you think would really help someone in your environment? Is there something about doing the work that you're doing that is unique, even as compared to the rest of the cybersecurity industry?
Well, you certainly have to be curious about how everything works. I learned about every industrial process, and you have to be really curious about understanding in great detail how a process works, what can go wrong. You don't need to be a chemical engineer or an electrical engineer, but you need to be able to ask the right questions of them to understand what a bad day looks like and how it can happen. And you need to be willing to learn about the old technologies, certainly. You need to be adaptable with that. You need to be willing to work without your modern tools, which can be very challenging for a lot of people. And you need to have that safety mindset. You need to care about those industrial consequences in people's lives and society functioning before caring about domain controllers being hacked or LLMs or techie stuff. What matters is that everybody goes home safe at the end of the day. That's what matters. And you have to shift your thinking from hacker, 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 Cobalt Strike, Metasploit, whatever, to is everybody alive? Did everybody go home today?
That's amazing. I'll tell you a little story. When I started my PhD in safety and reliability engineering, as I said, it was in international airports. I watched all of the episodes of Air Crash Investigation a couple of times, and it was just brilliant because I had this passion about looking what could potentially go wrong when you have a system that from the outside looks just perfect, everything runs smoothly, and you have that little thing that gets in the cogs and makes everything blow, and really working backwards. Okay, well, from there, doing a bit of a root cause analysis and looking at what are the failure modes, what are the different things that we should be looking for to design them better, to protect them better, to create controls on those for us to be safe.
I started out as an aircraft mechanic, actually. That's how most of us in this field have like a weird backstory, origin story. So my weird combination of an industrial thing and cybersecurity is I was a computer hacker who became an aircraft mechanic. So
that's brilliant. Can you tell us a little bit more about that? That's super interesting about your background, the different industries you worked in. Whatever can be shared, obviously.
I've done a lot of things in my life. I'm old and I've done a lot of things, and my journey is not representative of people's journey today, but I grew up on a farm and I learned to program at 7 or 8 because there was nothing else to do but use the computer in the farm in the 80s, and got a job during the dot-com era as a programmer and got involved in the hacking scene because you could do that as a teenager then. That was a different time. And when that all fell apart, I didn't have any choice but to enlist in the military. And they were like, what do you want to do? I said, what do you got with computers? And they're like, do you want to solder aircraft avionics and computer systems? Sure, give me some circuit boards. Cool. And so it was hard to get into cybersecurity, though. I mean, I wanted to do that, but at the time I didn't look like everybody who was doing that, and they didn't really want me there. So it was a long journey. I got a degree in network engineering. I did telecom for a while, and eventually I got a break. But the world is so different now. My journey is not like anybody's journey will be today. They face a lot of different and more increased challenges in breaking into the field. So yeah.
Absolutely. And fast forward, more recently, you recently moved to Australia. Now you live here. How are you finding it?
I'm the happiest I've been in my entire life. I'm so grateful to everybody here in the cybersecurity community who made me feel welcome and has let me be a part of the Australian cybersecurity community.
It's great. It's great having you here in Australia. Thanks so much for your time, Lesley. Today was great. Great having a chat. I'm sure that our audience will agree. It's been a beautiful conversation. You really cast light on an area that is not as spoken and talked about, which is also the intention behind these podcasts. Thanks again for being with us.
Thank you so much for having me.
No worries.